by u reference to the power of 2 times 1000. So that means that our variables that we created right now, they are not directly comparable. So what we could do, for example, for these two, we can create a new custom field function. So I select UU, I divide it by uref to the power of 2, which is 44.2 at the power of 2, multiplied by 1000. So this is UU over uref the power of 2. And you can do the same for VV. Now, before the time is ending, I can plot. Let's create. So in the exercise, the homework, we are asked to plot the velocity and Reynolds test profile. So basically, the velocity are made non-dimensional with respect to uref. The Reynolds stress, which is respect uref to the power of 2 times 1000, at x over h equal to 1 and equal to 6. So we need to create two more lines. So from domain, create line which is for x. Let's call this x equal h. So the x is 0.01, 1 centimeter. The y goes, so this is the one at the center of the domain, so minus 0.005. And z goes from 0 to the bottom of the wall to a z of you can choose that value. You can see that on the website these are plotted up to a y over h equal to 3. So that means that we can use 3 centimeters. So 0.03 to get the same range for the z. And create. We can do the same for x equal to 6 times h. We just need to change the x to 0.06 and create. To check that the lines you created are correct, you can go in the display, in the general tab. For example, you can plot the wall at the bottom and these two lines. So you should get something like this. So you see that now we have two perpendicular lines downstream of the step, where we can plot the velocity and the Reynolds stress profiles. There is also, again, if you want to compare the same chart with this website, you need to calculate y over h, which means that we can create even a new custom variable, for example, for the y over h. So that will be the z coordinate, so the coordinate perpendicular to the wall. So we can select this in mesh, z coordinate, over h. H is 1 centimeter, so this is 0.01. And we can call this variable as y over h. Define. So, for example, we can plot now the Once again, in this plot, we have that the y over h is in y-axis. So to do the same, get the same, we need to deselect point position on x-axis. So we can select now both y and x-axis function. I also deselect all the points, because if you keep that on, that will mess up things with your values. So on the y-axis, we select custom field function y over h. X-axis function, you can, for example, select the variable that we created, this uu over uref to the power of 2, for the two lines we created. So you should get something like this, for uu over uref to the power of 2 times 1000. Now I need to create all the other variables, so you can do the same as we did for uu over uref for vv and the u prime v prime, and also for u over uref, and then you can plot them along these lines as a function of y over h.
In the NASA website, it's only u prime v prime.
Yes.
So over the uu and vv.
I do have them.
Oh, okay, so it's a okay.
Yeah. Yeah, I can. So on the website you only have these values for u prime v prime that are plotted, but in the backstage profiles here you can find also the other values. So u prime, and v prime, v prime. So you can compare the results with this data. So you should do this for, so complete this case for this ST. So basically just calculate the remaining variables that you need to plot. So velocity and Reynolds stress normalized or made non-dimensional with respect to the reference velocity. And then you need to run also for the standard K epsilon and K omega and compare the results. Of course, once you have this case, basically you can save this case in file, write case and data if you want to save also your solution. So for example, this is K omega SST. When you're saving the case, you are also saving all the lines and the custom variables. So once you reopen the case, they are already there. So that means that once you will run this with the K omega standard, then all the variables and the lines are already there, so you just need to plot them.
Can you
So,
repeat how to save?
for saving the case and data, you need to file, write case and data.
Export it to XY file. And then convert it to
Okay, so thank you, and see you next week.